Hi everyone, we are students from University of Malaya and currently taking GIG1005 Social Engagement. Our group consists of 6 members and each of us are first year statistics students. In this video, we will teach you one of the topics in Form 4 syllabus, which is Chapter 5, the straight line. There are 5 subtopics in this chapter and we are going to cover one by one for you. For your information, this chapter will appear in SPM examinations for both Paper 1 and Paper 2. We will give some simple notes and teach you how to tackle the questions. So to begin, let's look at 5.1, gradient of a straight line. The learning outcome will be, you have to know how to find the gradient of a straight line using the basic concept. Let's start. Gradient of a straight line is the ratio of the vertical distance to the horizontal distance between any 2 points on the straight line itself. Looks very complicated? Never mind, let's translate into a diagram. This is a straight line AB. When you have to find the gradient for AB, it is equal to vertical distance divided by horizontal distance. It is same with above here. So the vertical distance will be AC. Horizontal distance will be BC. So AC divided by BC, you will get the gradient of AB. For your information, the symbol for gradient is M. So gradient of AB equal to MAB. This is the only formula in this subtopic. Whenever you are asked to find the gradient of a straight line, just always imagine a triangle. So it's easy for you to find for the vertical distance and then horizontal distance. Let's look at example 1. Complete the table below. From the diagram, you have to complete the vertical distance, horizontal distance, and finally the gradient M. Vertical distance is something like this, horizontal distance. So now you have to count for the vertical distance. It is a triangle here, right? It is a triangle. So vertical distance, count 1, 2, 2 units. And then horizontal distance will be 4 units. So write 4 here, 4 units. So again, the formula for gradients will be vertical distance divided by horizontal distance. So 2 divided by 4, and you can simplify into 1 over 2. Very easy, right? Now, have a look at example 2. Find the gradient of straight line PQ, QR, and PR. So there are 3 parts here. We do it one by one. First, look for PQ. So for PQ is here. We just focus at here, so you won't get confused. Again, the formula apply. Vertical distance divided by horizontal distance. So count for the vertical. 1. Horizontal. 2. So gradient for PQ is MPQ equal to 1 over 2. Done. Now, for QR. QR, just focus at here. Count again. For the vertical distance, 3 units. Horizontal, 6 units. So gradient for QR equal to MQR 3 over 6, and you can simplify into 1 over 2. Done. Now the final part, PR. PR is for the whole straight line. So count again. For the vertical distance, 4. Horizontal distance, 8. So gradient for PR and PR equal to 4 over 8, and you can simplify into half. So coincidentally, all the gradient here is equal to half. Now, let's move to example 3. Given the gradient of a straight line, EF is 2 over 3, and the horizontal distance is 12 units. What is the vertical distance between point EF? So first, extract all the information from the questions to the diagram. The horizontal distance is 12 units, so horizontal distance here is 12 units. And we have to find for the vertical distance here. We don't know what is that. So let's name it as x. So apply the only formula again. Gradient equal to vertical divided by horizontal. We already know the gradient is 2 over 3. So right here, 2 over 3 equal to x divided by 12. So doing some simple mathematical computations, you will get x equal to 8 units. So the answer will be B. Done. Now let's move to example 4. Given Ln equal to 16 units and Mn equal to half of Ln, find the gradient of Lm. So again, extract all the information to the diagram. Ln equal to 16 is here, and we don't know what is Mn. From this expression, we can find for the Mn. Mn equal to half of Ln and Ln equal to 16. So Mn equal to 8 units right here. Then use the formula again. Gradient equal to vertical distance divided by horizontal distance. So it's 8 divided by 16. You will get half. So the answer will be D. Now, let's look for the final example. Ali hangs a flat string from the top of the building X to point Z as shown in the diagram. Given the height of the building is 30 meters, if the gradient is 5/6, find the distance of YZ. So all the information here is already written in the diagram. We have to find for the YZ. We don't know what is YZ. So apply again the formula. Gradient equal to vertical divided by horizontal. We know the gradient is 5/6. 5/6 equal to vertical. Vertical is the height of the wall is 30. Then the horizontal is YZ. At here, you can do some simple cross multiplications rule. By this, you will get 5YZ equal to 6 times 30 and move the 5 to the right side. You will get YZ equal to 36. The answer is C. So, the only formula that you have to know in this subtopic is only this. Gradient equal to vertical distance divided by horizontal distance.
Let's continue with the subtopic 5.2, gradient of the straight line in the Cartesian coordinates. In this subtopic, we are going to learn on how to find the gradient of a straight line in Cartesian coordinate. So now let's start with the formula of gradient. We can see that the formula of the gradient of the straight line which passes through the P and Q is given by the formula MPQ equals to y2 minus y1 over x2 minus x1. After studying the formula of gradient, let me show you some example. Example 1. From this diagram, we can see that the point P and point Q were joined by the straight line. The question is given to find the gradient of the straight line joining 2 points between P and Q. How to solve example 1? Here is the solution. First, we need to write down the coordinates of P and Q so that we know which is our x1, y1, x2, y2. Second, we sub the coordinate of P and Q into the formula of gradient, which is y2 minus y1, x2 minus x1. After that, we just do some simple math calculation, then we are able to get the answer, that is 1/3. Next, we continue for the following example. A straight line with gradient -3 passes through point A and point B. Find the value of P. From here, we know that the gradient is -3 and we have 2 points. So we just use the formula of gradient and sub all the numbers into this formula, which is y2 minus y1 over x2 minus x1 equal to gradient. From here, we know that P is our y2. So we just do some simple math calculation again, and we can find the value of P, that is -3. After showing some example, let us do some SPM practice. Question 1. The diagram above shows a straight line of ABC. Find the value of P. To solve this question, first we interpret the diagram. This is a straight line consisting 3 points which are A, B, and C. Before we find the value of P, we need to calculate the gradient first. So we write down the coordinate of A, B, C. We found that the value of P is the coordinate of A. Hence, we choose to use the coordinate of B and C to calculate the gradient. After substituting the coordinate of B and C into the formula of gradient, we know that the gradient of BC is equal to -1. Since the gradient of BC is equal to the gradient of AC, by using the gradient of BC, we substitute the coordinate of A and C into the formula of gradient and do some simple calculation. We find that the value of P is equal to 8. Question 2. The diagram above shows two straight lines PQ and QR. Given the gradient of line PQ is 2, find the coordinate of point Q and the gradient of QR. Next, let me explain the solution. Question 2a is to find the coordinate of point Q. Since we know the gradient of line PQ is equal to 2, then we sub the coordinate of P and Q into the formula of gradient and do some calculation. Thus, the value of P is equal to 6. Next, question 2b is to calculate the gradient of QR. After getting the coordinate of Q, then we do the same thing, which is sub the coordinate of QR into the formula of gradient and do some calculation. Then we are able to find that the gradient of QR is equal to -3/2. After trying all the example and SPM practice, I believe you can get the idea on this topic. So we are going to try some past year question. This question is from paper 1. The question is, the coordinate of point R are -2, 3, and the gradient of the straight line RS is 2. The coordinate of point S could be, so from this question, we know that we need to find the coordinate of point S. Hey, let us try to solve this question. First, let the coordinate of point X be xy. Therefore, the gradient of RS is equal to 2. So, we substituting the coordinate of point R and S into the formula of gradient until we get the equation y equal to 2x plus 7. So now we look at that question. Then we found that from the options A, B, C, and D, all x is equal to 2. Third, we substituting the x equal to 2 into the equation y equal to 2x plus 7. Then we managed to get the y equal to 11. Therefore, the coordinate of x is equal to 2, 11. So the answer is D. Let's try our last question. This question is from SPP 2015. This is a paper 1 question. The diagram shows a straight line RS on a Cartesian plane. The gradient of the straight line RS is, so this means we need to find the gradient of the straight line RS. By solving this question, first we need to interpret the diagram. From this diagram, we can see that we only have one coordinate, which is point R. So means we need to find another one coordinate, as we are unable to calculate the gradient by using only one coordinate. Then we found that the point of origin is joining with this straight line RS. So we choose the point of origin as our second coordinate. Then we write down the coordinate of point R and the coordinate of point of origin. O is represent the point of origin. Therefore, we are able to find the gradient of OR. By using the gradient formula, we substituting the coordinate of R and O into this formula and do some calculation. So we can know that the gradient of OR is equal to 5. Since the gradient of OR is equal to the gradient of RS, so we know that the gradient of RS is also equal to 5. Thus, the answer is D.
Okay, so now we are going to learn the next subtopic, which is intercept. So the learning outcome is to understand the concept of intercept. There are two intercepts, x-intercept and y-intercept. So the x-intercept is the point where the line crosses the x-axis. So at this point, y will equal to 0. And then the y-intercept is the point where the line crosses the y-axis. So at this point, x will equal to 0. So now we are going to learn how to find intercept from a graph. So from this graph, you can see that the point on the x-axis is 5, 0. So we will call this the x-intercept. And on the y-axis, the point is 0, 4. So we will call this the y-intercept. Now we will learn how to find an intercept from an equation. So given the following linear equation, 3x plus 2y equal to 5. To find the y-intercept, we will just need to substitute x equal to 0 into this equation, as we know that at y-intercept, x is equal to 0. So we will just need to substitute x equal to 0, and then we will get y equal to 5 over 2. So the y-intercept is 0, 5 over 2. So to find the x-intercept, it is the same concept. You will just need to substitute y equal to 0 into the equation. And then we will get x is equal to 5 over 3. So the x-intercept is 5 over 3, 0. Okay, so now we'll look at example 1. In the diagram above, the gradient of the straight line is negative 2 over 3. Find the x-intercept of the line. Okay, so we already know the gradient of the line, and also from the diagram, we can know that the y-intercept is equal to 10. So we can use the formula m is equal to negative y-intercept over x-intercept to solve this question. So the solution, already given the gradient and also the y-intercept, so we'll just need to sub our value into the equation, and then we'll get x-intercept equal to 15. So the answer is D donkey. The next example is from SPM past year question. So this question is from SPM 2010. So diagram 15 shows two straight lines KL and also LM on a Cartesian plane. It's given that the gradient of KL is 2, and then we need to find the x-intercept of KL. Okay, so from this Cartesian plane, we can know that the length of here is same as here. So the length of here is 3. So definitely here will also equal to 3. Okay, so now we know the y-intercept is equal to 3. Now we have the information of gradient and also y-intercept. So we can use the previous formula, which is m is equal to negative y-intercept over x-intercept. We just need to substitute the value inside, and then we'll get x-intercept is equal to negative 3 over 2. Okay, so the next question is from SPM 2016. In diagram 19, Mn is a straight line drawn on a Cartesian plane. Given the gradient of Mn is 3, find the x-intercept of Mn. So the gradient of Mn is already given, but we doesn't know the y-intercept. And also from the Cartesian plane, we cannot know the y-intercept. So we need to use a different formula, which is m is equal to y2 minus y1 over x2 minus x1. So this formula can be used when gradient and also coordinate of 2 points are involved. So for this question, yes, gradient is already given, and then it also involves the coordinate of 2 points, the point here and also the point here, which is also the x-intercept that we want to find. So the solution, given the gradient is equal to 3, and then we'll use this equation. Okay, so now this point is equal to 1, 6, and then this point is equal to x1, 0. The x1 is the x-intercept that we want to find. So we will just need to sub these two coordinates and also the gradient into this formula to get x1, which is the x-intercept. Okay, so 3 will equal to 6 minus 0 over 1 minus x1. 3 minus 3x1 will equal to 6. 3x1 will equal to negative 3, and then x1 will equal to negative 1. Okay, so now we know x1 is equal to negative 1. So the answer x-intercept of Mn is equal to negative 1.
Let us continue with the subtopic 5.4 equation of a straight line. Our learning objective for this subtopic is to understand and use the equation of a straight line, and also to understand the concept of a point of intersection of two straight lines. The equation of a straight line can be divided into two types. First type, slope-intercept form, which is y equals to mx plus c. Second type, point-slope form. When there is given one point and the gradient of a straight line, we can use y minus y1 equals to m bracket x minus x1. When there is given 2 points which lies on the straight line, you can use the equation y minus y1 over x minus x1 equals to y2 minus y1 over x2 minus x1. General equation of a straight line is y equals to mx plus c, which the m is represented the gradient of the straight line, and the c is represented by the y-intercept. When two straight lines intersect at one point and the point are known as point of intersection. To find the point of intersection, we need to know the equation for each of the lines. At the intersection point, the value of x and y are the same, so we can equate these two equations of the straight line to find the value of x. After getting the value of x, we can substitute the value of x into one of the equations to solve for y. Next, let us come with some example. For the first example, suppose that we want to find the equation of a line which has a gradient of 1/3 and passes through the point 1, 2. In this example, the gradient will be given and the point which passes through the line will be given. You can label as x, y. You can directly substitute the value of m into the general equation y equals mx plus c, and then substitute the x and y value of the point given to get the value of c, which is 5/3. And finally, the equation will be found, which is y equals to 1/x, 1/3x plus 5/3. Example 2. Find the intersection of the line y equals to 3x minus 3 and y equals to 2.3x plus 4. For this question, we should equate both of these equations to get the value of x, which is finally x equals to 10. After getting the value of x, we can substitute it into one of the equations. Let's just choose this one first. Y equals to 3 times 10 minus 3, and then y equals to 27. We can also use another equation and the answer should be same. Let's just see. Y equals to 2.3 times 10 plus 4. 23 plus 4. And finally, the answer is also 27. Thus, the intersection point is 10, 27. After passing through some example, let us come with some SPM practice. In the diagram above, a straight line 5x plus 7y plus 335 equals 0 intersect with the x-axis and y-axis at R and S. Determine the gradient of the straight line RS and the x-intercept of the straight line RS. For the question A, to get the gradient, we should rearrange this equation into its general form, which is y equals to negative 5/7x minus 5. And we can compare with y equals to mx plus c. Thus, we know that negative 5/7 is the gradient of Rs. Question B, we know that the x-intercept is when y equals to 0, which is the value of R. We can just substitute the value of y, which is 0, into the equation so that to get the value of x, which is negative 7. The value of x represented by the x-intercept of the straight line. Next, let us come with some SPM partial question. It is given that the equation of a straight line which passes through the point is y equals to negative 4x plus c. Find the point of intersection of the straight line and the x-axis. To determine the value of x-intercept, we should complete the equation first. From the question, we know that the equation of straight line y equals to negative 4x plus c. And also, the point which passes through the line are also given. We should substitute the point into the equation to find the value of c first. And we get c equals to 8. Finally, the final equation are be found. Next, to find the x-intercept, we should substitute y equals to 0 and the x value is 2. Thus, the point of intersection of a straight line of the x-axis is 2, 0. And the final answer is B. Let's study our last question, which is from SPM past year 2013. It is given that 3 points P, Q, and R lies on the Cartesian plane. S is the midpoint of the straight line PQ. Find the gradient of the straight line SR. To solve this question, we should determine the point S first, which is known as the midpoint of PQ. The formula of midpoint is known as x1 plus x2 over 2, y1 plus y2 over 2. And from the question, we know that P is 4, 6. So we can sub it as x1, y1, and the q as x2, y2. And substitute the value of P and Q into the formula, we can determine the value of S. And finally, by knowing the value of S and R, we can finally get the gradient of the straight line by using the formula m equals to y2 minus y1 over x2 minus x1. So finally, the answer is negative 5 over 8. The gradient of the straight line is negative 5 over 8. The answer is A.
Now we move on to the parallel lines. In this lesson, we will learn that how to find the gradient and equation of parallel lines. First, we look at the gradient of parallel lines. If two straight lines have the same gradient, then they are parallel. It means that if gradient of line AB equals to gradient of line CD, then line AB is parallel to line CD. First statement implies that if two straight lines are parallel, then they have the same gradient. It means that if line PQ is parallel to line RS, then the gradient of line PQ is equal to the gradient of line RS. Next, let us do an example. Determine whether the two straight lines are parallel. To solve this type of question, first, we need to find out the gradient of both straight lines by changing the equation into the form y equals to ms plus c. Then by comparison, we will know that whether they have the same gradient. If both gradients are same, it means that both straight lines are parallel to each other, and vice versa. Now, we look at the solution for A. First, we need to change the equation of the first straight line, 3y minus 6x equals to 9, into the form y equals to ms plus c, which is y equals to 2x plus 3. Then, we will find out the gradients for both straight lines. And we will get that both gradients are the same, which is equals to 2. Therefore, the two straight lines are parallel. And for B, we do the same steps as for A. We change both the equations of straight lines into the form y equals to ms plus c. And we will get that first gradient equals to 5 over 4, and second gradient equals to 4 over 5. Since both gradients are different, therefore the two straight lines are not parallel. There are 4 steps for finding the equation of parallel lines. Step 1. let the equation of the straight line take the form y equals to mx plus c. Step 2. Find the gradient of the straight line from the equation of the straight line parallel to it. Step 3. Substitute the value of gradient and the x-coordinate and y-coordinate of the given point into y equals to mx plus c to find the value of the y-intercept c. Step 4. Write down the equation of the straight line in the form y equals to mx plus c. Now, let us look at the first example. Find the equation of the straight line that passes through the point negative x 2 and is parallel to the straight line 4y plus 3x equals to 12. Okay, since the equation of the straight line that we want to find is parallel to the given straight line 4y plus 3x equals to 12, so that we can find our gradient of the straight line from the given equation. And we get that n equals to negative 3 over 4. Now, we want to find the y-intercept of the straight line. We will use y equals to mx plus c as our formula. At the point negative x 2, we will substitute m equals to negative 3 over 4, x equals to negative x, and y equals to 2 into our formula. And we get that c, which is y-intercept, equals to negative 4. Finally, write down the equation of the straight line in the form y equals to mx plus c, which is y equals to negative 3 over 4x minus 4. Next, look at the example 2. The straight lines MN and PQ in the diagram above are parallel. Find the value of Q. Since the line MN and line PQ are parallel, we know that they have the same gradient. Therefore, we can use the formula M1 equals to M2, which is MNN equals to MPQ by using the gradient formula y2 minus y1 divided by x2 minus s1. Then we substitute the point in the line MN and line PQ into the formula. Then we simplify it and we will get the final answer Q equals to 5. Now we move on to the SPM question. This question is question from paper 2 of year 2006. The diagram shows a straight line KL and a straight line MN drawn on the Cartesian plane. KL is parallel to MN. Find A. The equation of the straight line MN. B. The x-intercept of the straight line MN. Next, we look at the solution for A. Since KL is parallel to MN, we know that they have the same gradient, which is gradient of MN equals to gradient of KL. By substituting the points in the line KL into the gradient formula, gradient of MN is equal to negative 3. Now, we want to find the y-intercept of the straight line MN. We will use the formula y equals to mx plus c. And we know that the straight line MN passes through point n7 negative 2. So, we will substitute x equals to 7, y equals to negative 2, and n equals to negative 3 into the formula. And finally, we will get that y-intercept c equals to 19. Therefore, the equation of the straight line MN is y equals to negative 3x plus 19. Now, let's look at the solution B. The question asks us to find the x-intercept of the straight line MN. As we know that at x-intercept, y equals to 0. So, we substitute y equals to 0 into the equation of line MN. Then, we will get that x is equal to 19 over 3. And the x-intercept of the straight line MN is the value of x, which is 19 over 3. Next, let's do another SPM question. This question is question from paper 2 of year 2011. In the diagram 6, PQRS is a trapezium drawn on a Cartesian plane. PQ is parallel to SR and O is the origin. The equation of the straight line PQ is 3y equals to kx plus 5, and the equation of the straight line SR is y equals to 1 over 2x plus 1. Find A. The value of k. B. The x-intercept of the straight line PQ. Now, we look at the solution A. Since we know that line PQ is parallel to line SR, therefore they have the same gradient. And we want to find the value of k. First, we need to change the equation of line PQ into the form y equals to mx plus c. Then, we find the value of k by comparison, which is gradient of PQ k over 3 equals to gradient of SR 1 over 2, and we will get that k equals to 3 over 2. Next, B. We want to find the s-intercept of the straight line PQ. At s-intercept, y equals to 0. We substitute y equals to 0 into the equation of line PQ and get that s-intercept, which is x equals to negative 10 over 3.
Next, our group would like to discuss about some questions from paper 2. Here is question 1. Determine whether the straight line 3x plus 2y equal to 6 is parallel to straight line 2y plus 3x plus 2 equal to 0. The solution is, we change the form of the two straight line into general form, which is y equal to mx plus c, to find out the gradient of each line. If the two straight lines have the same gradient, they are parallel to each other. Let's move on to question 2. In the diagram, O is origin. Straight lines Ln and OK are two parallel lines. Find A. The equation of the straight line Ln. B. The x-intercept of the straight line Ln. For part A, we first find out the gradient of straight line Ln, which is same to the gradient of straight line OK because they are parallel to each other. After that, let's say the equation of Ln is y equal to mx plus c. We have the coordinate of m, which is located at the straight line Ln. We substitute m equal to 3, x equal to 6, and y equal to 10 into the equation. Then we find out that the c equal to negative 8. Thus, the equation of straight line Ln is y equal to 3x minus 8. For part B, after we find out the equation of straight line Ln, we substitute y equal to 0 to find out the x-intercept of straight line Ln. When y equal to 0, x equal to 8 over 3. Therefore, the x-intercept of straight line Ln is 8 over 3. Let's continue with question 3. In the diagram above, PQRS is a trapezium on a cartesian plane. Find A. The coordinate of point R. B. Equation of straight line RS. C. Y-intercept of straight line RS. D. X-intercept of straight line RS. E. Equation of straight line QR. For part A, we must know that in the trapezium there are two sets of parallel lines. Indeed, there are QR is parallel to PS and PQ is parallel to RS. First, we set the coordinate of R to X and Y. The Y of R is same as the Y of Q because they are at the same height, which is Y equal to 4. After that, we must find out the X. We look to the parallel lines, which is PQ gradient is same to the gradient of RS. Therefore, we find the gradient of PQ, which is 2 and equal to the equation of gradient of RS. We can find the X is equal to 6 for R. Therefore, the coordinate of R is 6, 4. For part B, we want to find the equation of straight line RS. Since we have the gradient of straight line RS and the coordinate of R, therefore we substitute all the information into the general form of equation, which is y equal to mx plus c, to find the c. Thus, the equation of straight line RS is y equal to 2x minus 8. For c, we look to the equation of straight line RS and we can see that the negative 8 is the y-intercept of straight line RS. For D, we can find the x-intercept of straight line RS through the diagram. We can see that the point S is located at coordinate 4, 0. Therefore, the x-intercept of straight line RS is equal to 4. For E, since QR is horizontal line, we apply the concept of horizontal line and we can conclude that the equation of QR is y equal to 4, where they intersect the y-axis at y equal to 4. Our video has come to an end. Our group would like to show our appreciation to our lecturer, Dr. Lee, for her guidance to create this video. Thanks for watching.